Hi, this video, we're going to complete the exercise of VLAN routing, revisiting the topic of VLAN routing, router on a stick with the static network address translation. And also we're going to add the discussion of the STP. Uh, so we are going to download this exercise packet tracer file here, and we'll open it with packet tracer and the document that we're going to go through to configure the packet tracer. So this is the document. We are going to go through that first. The objective is to review and also deal with more complex router on a stick, and which we will also first time introduce the static routing, static network address translation syntax. And we then, we are going to leave the router alone and then use the VTP server as a VLAN router, VLAN routing, and also illustrate what to look for the STP configuration. And of course, the first thing is to set up all the hosts, call it A9, A10. A stands for the switch A, and B stands for switch B, easier to remember. So this is B9 and B10. And then 9 is the VLAN 9, and 10 is VLAN 10. So on the VTP server here, on the switch A, I call it A9. That's a switch A, VLAN 9. And the other host is on the switch A, and it's VLAN 10. So it's at 10.10, 9.9. And then this one will be 9.33 and 10.34. So we are going to use those stations to illustrate how do we ping each other at different VLAN. And again, the ASA is configured as the 10.10.10.10. This IDF switch is not part of the STP domain. And this is our router on the stick here. And the interface here, the first interface, GI000, we configured to 104 and for VLAN 1. And this VLAN 1 is 204, and VLAN 1 is 212 here. And of course, the trunking for this particular interface, it will have a VLAN 9 as 9.1, 10.1, and this is 9.2, 10.2, so on and so forth, okay? So first thing we have to set up is the host, which we already did many times. And I believe I already pre-configured all those 4 hosts to save you some time in there. But you just make sure you know how to change and how to set it up. Currently, it's been set up to default gateway 9.1 for the router on a stick. So this one default to the 9.1 here. Now the configuration for the router on a stick, config T, no domain lookup, host name, interface is GI000, and then we give it IP address of 10.10.10.104. So this is 10.10.10.104. It is the IP address that's given to interface 0, which will connect that to the IDS, the IDF switch. And then we have a sub-interface of GI001. We do not give IP address was the 001, but we give IP address of the sub-interface, VLAN 9, VLAN 10 as the default gateway. All right, so this is the syntax, which is pretty much a review of what we have done before. And then this is setting up the default gateway to 10.10.10. As far as VTP server, now we are going to have a new switch as a client. So we make the switch A as the VTP server, and we give the name. The important thing is VTP domain. When you add a new switch to it, you have to choose the same name and then make it a client. Okay, so it will join in to the BGP domain. And that's in addition to the last exercise we went through. Now, let's go back to, yeah, we already finished the routers configuration explanation. For the main switch here, again, the first port, we make it VLAN 1. And the second port in here, we're making it a trunk port, right, to allow all of them. And the VLAN 3, we make it allow VLAN only 9 and 10. So the trunk port 3 here, the 1, 3, we are going to connect it to here, and it allow only VLAN 9 and VLAN 10. Okay. So the VLAN, the GI102, that is one allow VLAN all of them. Okay, so allow all of them is this one. So when we come, if you wanted to draw, draw those image yourself, then you make sure that this is the trunk that allow all of the VLAN. So this is in our port number 2. You're going to come like this. So all the VLAN 1, 9, 10, it can all pass here. But in here, this connection, we only allow 9 and 10. The main reason is in here, we have this particular port that's in here. We try to later on, when we do the VLAN routing, we are going to create a new line directly coming from here to the IDF switch. Then if we allow VLAN 1 to go through from here, then we might form a loop going in here and get the VLAN 1 become a looping. So we try to avoid that by limit its traffic to only VLAN 9 and VLAN 10. Okay, so this is the switch B. Switch A is the STP server. And then interface 9 is connected to the host A9. Okay, so this is to connect onto the host A9. And then of course, then you know the port number 10 is connected to the host A10. All right. Of course, this is VLAN 10, and whatever IP you gave it to the host 10, it really doesn't matter. Let me put up this. So the packet tracer file here. And you can see that for this VLAN 9, you can give it anything. Doesn't even have to be 9.9, whatever the IP, because it's layer 3 information, right? Just want to make sure that VLAN 9, you set up the same IP layer 3 network in here. And we just give them, we just have to connect the port number 9 as VLAN 9, port number 10 as VLAN 10, all right? And this is the port allows, the trunk only allows 9 and 10. And this connection will allow all of the VLAN on the trunk. So this is a trunk and this is a trunk. And the rest is just the VLAN port. By default, everything is VLAN 1, right? So then the interface VLAN 1, we configure the BTP server. We give it an IP address 10.10.10.204. We are not going to make it a router now, but we just pre-configure everything so that it's ready to route amongst the VLAN 1, VLAN 9, and VLAN 10. And of course, so the default gateway, and most importantly, don't forget the IP router. Make it a router. Now this is a client. Of course, the main difference is that the host name is the client. You can call it anything, but it's easier to identify. It's very important that we set the domain name the same, and choose the mode as client. And then the interface 1 is VLAN 1, and then interface 2, we make it a trunk to allow all. So the interface 2, or the interface 1/0 port number 2, connected to the server 2 to 2. And then the 3 to allow, 3 is also a trunk port to make it allow all of them. And then port 9 is VLAN 9. Port 10, again, VLAN 10. And then we give it the VLAN address in here and enable the routing. Okay, so we continue on to configure the ASA. We set the VLAN 1 as the inside interface, and then we give it an address of 10.10.10.10, just like what we have done before. And then the ASA has 8 ports. So we just tell them that, hey, from port number 1 through port number 3 is VLAN 1, and port 0 that is VLAN 2, and port 7 is VLAN 3. We're not going to use VLAN 2 and VLAN 3. It could be a DMZ one and outside, or whatever your topology is. And we only focus on the internal network, which is VLAN 1. So VLAN 1 is 10.10.10.10. So we are going to also install, copy and paste the ASA configuration to the topology. Now, the testing procedure is that we're going to follow this to ping from the switch A to switch B to the CNASM 10.10.10.10. It will fail after we configure it. Of course, the trunk between the student router and the switch A, it only allowed VLAN 9 and 10. Okay, so let's take a look at the topology. Okay, so if you look at the topology on the test procedure number 1 from the switch here, even though they are configured at 10.10.10, 204, 10.10.10, 212, these two switches can ping each other. Of course, they belong to the same domain with the trunk port connected together. But when they try to ping the 10.10.10, and this trunk port only allow VLAN 9 and 10, so that when you try to pass it, there isn't any line here, the physical connection for it to work. So it will fail, okay? And then we are going to ping again on the second one. Second test procedure is to ping 99 to the 9.33, and then to 10.10 and 10.34. And also we ping the Cisco router 104, and also the 9.1, 10.1, the router, and both the switches. It should all work. So let's explain that. So the step number 2 is that we ping from 192.168 and 9.9 here. When we want to ping the 10.10, your default gateway now is going to come here, and you're going to default gateway it to 9.1, which is there. And of course, VLAN 9, it allow it to pass, come back there. And then you will come back here to go to VLAN 10, 10.10. So of course, the 9.9 can ping 10.10. And when you want to ping the 9.33 from the 9.9, it's going to come here and directly pass the trunk without the default gateway and reach the destination. And from the host A9 here, you want to ping host B10. Then you're going to go to different network. So you're going to rely on the router. So you come in here, default gateway, and then the default gateway will forward it back and go to the trunk port, and then go to 10.34. And when you try to ping 10.10.10.104, then you, again, it's not on the same network. You're going to rely on your router default gateway. So you send it through trunk VLAN 9, go to your default gateway 9.1, and 9.1 look at it and say, hey, yeah, I do know 104, that's myself. So I'm going to not forwarding any further, just directly reply to you and say, hey, this is the echo reply to you. And if you want to ping the 10.10.10.204, okay, then let's follow it when you go from here, let me go ahead and stop right here and let's take a look at that. So we already explained when we ping all this will work, but so including if you want to ping the 9.2 and 10.2, 9.3, and 10.3, including the VLAN 9 here, VLAN 10 here, then of course VLAN 9 and you can directly ping it, and VLAN 10 you will go through your router. So everything will work except a few boxes, which is number 3 here. When we ping to 10.10.10.10 and 204 and 212 will fail. Okay, so from this box, when we try to ping 10.10.10.10, so everything will work. I just explained all the data flow, and you can follow the logic. But with 3 boxes, you cannot ping. In here, the 9.9, when you want to ping 10.10, and you go up here, you will follow the default gateway here. And the 104 say, hey, 10.10, 104. You want to ping 10.10.10, no problem. I can actually forward it out to the switch to here. Well, this is the same issue that we had before, because the router at the beginning is not really doing any NAT by default. If we just forward it out, we of course then will configure a NAT to make it successful. So what happened is when you forward the packet here, 9.9, this box doesn't know how to get back. Then of course you have to add a route for it to go back. But we're not going to do that. We are going to introduce a new syntax to do a static NAT. So we will configure the static NAT for the 9.9 in order to ping the 10.10. Now we also have an issue of pinging the 10.10.10.204 and 212, because when you go out here, there isn't any path for it to reach the 10.10.10 network. 10.10.10 is connected to here, so there isn't any link that we can actually make the ping to happen. So when you are 9.9 send to the 9.1, it will just broadcast out here, and it can only reach the 10.10.10.10, and we're going to solve that problem as well. So let's take a look at the solution here. Is that we are going to say, hey, IP net inside source static. So this is the keyword. Say IP my network address translation. The inside the original source, we are going to statically translate that to from the 9.9, and I'm going to translate that to the outside of 102. And the rest is the same. We don't have to do all 4 of them, but you can copy it and paste it all if you like. And then again, we're going to set the interface of the router and say, hey, which one is the inside? Oh yeah, if you come from the VLAN 9 or VLAN 10, you are the inside. And where is the outside? Well, the GI 000 is the net outside. So with syntax is like this. So it's pretty straightforward. You just define which one's inside, which one is outside, and then give it the IP address for it to translate. So after you've done that, the host A9 IP address will be statically, then we'll translate it to the 102 by the Cisco router. And then the ping, when you ping the 10.10.10.10, then the student router will function as the proxy to answer the CNASM's ASA reply. So when this one tries to ping 10.10.10, it will come here and it'll be translated to 10.10.10.102. And this one 10.10.10.102, they say, oh yeah, it's the same network. I don't need any static route. Reply to 10.10.10.102, and this one will be the proxy for the 10.10.10.102. And then the communication come back here. Then it will, because it's from the 10.10.10 network, and then it will be forwarded out through VLAN 9, coming back here to the VLAN 9 port. Okay. And then we are going to, this is the end of the router on a stick portion of the exercise. So before we move on to the next one, we are going to do the hands-on. So I'm going to put the document on the side now, and we are going to Here. On the 3560 switch, this is the before configuration. We are going to, of course, have to power it on first. And for all the switch, let's power it on. Then let's configure the router first. On the CLI. So in our router here, what we will do is we will then config T, no IP domain lookup, all that, and we configure all the routing. But we didn't do any static translation. We just enable it, all the interfaces, so that it's ready to forward the packet. We paste it, and that's it for that. Now we need to configure the VTP server. Always the server first, of course. And say no for the GUI interface and enable. So get ready for our syntax. So this is our switch A. Now, since we already explained all of them, we may as well just copy the whole thing, one page at a time. Copy, and we go to this, and we paste it. So it's creating VLAN 9 anyways for us. Now we're going to create VLAN 10, and then give all the VLANs an IP address. P. Yeah, IP is 204. Paste it in. Last one is the switch B. Okay. Don't copy across the page. So sometimes they have control characters there. Right. CLI. No. Enable. And let's paste it in. And of course, this IP is 212. And then the last line is IP routing, of course. And copy. And we go to this one. And let's paste it. So after we've done that, now we have all the configuration in, and I already input this one, I believe, in there. So you look at the configuration, the Ethernet. Ooh, I haven't. So we just have to take some time to put it in. Okay, so from this 9 if we ping the 10 to 10, it will work because the packet is going to go here, come up, and come back down, and then go to the 1010. And you, of course, we can actually do the simulations because that's one of the advantage for the simulations. And we can just go ahead and edit the filter. Just allow the op and ICMP. All right. And in here, we're going to run the command. And once we run the command, we can actually make it run that. It will tell you that the packet will then go to the default gateway to the student router. And it's going to come back and then reach the destination. And the route is going to follow exactly what's on the visual traveling path there and completed the ping. Okay, so that is the simulations for that. All right, so let's go back here. Then I'm not going to record all the detailed ping at this step. You can ping everything except you cannot ping the 10-10-10 network here because 10-10-10 network, as we explained, you go in here and you can reach the 10-10-10, but it doesn't know how to get back. And we're going to fix it with the static route here. And when you try to ping the 204 and the 212, you have no route coming back because it only allows VLAN 9 and 10. Okay. So we are going to come here, take a look at our documentation here. So we will fix it with the static routing by copying those and put it onto the side. And let's go to the router here. And let's paste it in so that it's going to be translated to that if it coming from the VLAN 9 or VLAN 10. Copy and paste. And if you're coming from VLAN 10, you will be also translated. Depends on your IP address. And we only care about the VLAN address. We don't know what IP you're going to use. You can use any IP address you want. So if you come in here from VLAN 9, you will be translated to that, and so on and so forth. Now it's defined outside. Copy. Paste it. Okay, once that's done, then if you ping it, it's going to go here. And if you put a sniffer here, which I'm not going to do it again, so you will be able to ping the 10-10-10 now. And that 10. So now, if you sniff it here, you will see it. It's been translated statically to 10-10-10, 102. That's been translated to. Now, if we ping 204 and 212, as the document has explained, there is no route, no line. If you go in here and you go to this default gateway, it can't go anywhere. So we're going to first change it to the default gateway to 9.2 at this point. So in here. So now the last part, we're going to configure the inter-VLAN routing, which is the review of what we had previously done. And this router, this switch, we're going to make it inter-VLAN router. And we'll try to solve the problem for it to actually also be able to ping the 10-10-10-10. So what we will do is we'll connect one line directly to here. And it's not going to be a loop, even if we allow VLAN 9, 10, and even if we allow VLAN 1 here. The reason is the 10-10-10 network in here is connected to GI000, and this one is GI001. So you don't have a direct connection from the switch to a switch to connect to that. So when you have a broadcast on VLAN 1 on 10-10-10 here, it will stop right here on the GI000. It's not going to forward it to the GI001 subinterface of VLAN 1 and form a loop. So even if we do that, it will be okay too. But of course, just visually, it'll be nice that you separate those VLANs so that the unnecessary traffic will not accidentally goes in. Okay, so let's complete the exercise. We are going to switch the default gateway. In this case, we'll change that to 2. And then here, of course, we're going to change that to 2. So 10.2, and this one, you are going to change the configuration to 2. And in here, we're going to change that to 2. So after we've done that, then everything is going to the inter-VLAN routing. And of course, when you ping that, you'll see the packet is not going to go out to that anymore. So I'm just going to show you one of them. So if we ping 192.168.10.10, so in here, you're going to see it work right away because it's inside the same VLAN fabric. And if we do the simulations here, and just do that again, and you will see the packet travel to here, and then it's directly go through the inter-VLAN routing and coming back to you. So that's it. We just proved the concept of that. And then now, if you're going to go to the 10.10.10.10, it will be forwarded as well. So let's try that. Let's do 104, of course. The 10.10.10, 104 on top. Pin the top one. Oops, type it wrong. So the packet will send it to here, and then of course, well, you would try to go there, but it still failed because you see there's no VLAN 1 unless we allow VLAN 1 to pass through. Otherwise, it won't get to that point. So you're going to fail on that. Now we are going to fix it by, instead of just allow a VLAN 1 here, we're going to fix it by create a separate line here. So we don't want it to cause any potential loopback. So we're going to add a line here, click here, and then in the handout told you that you can actually connect this line into port number 3. So once we connect it, then when you want to ping the 10.10.10.10 now, you go in here. This is VLAN 1. So VLAN 1 will be forwarded here because VLAN 1 can't go out here. So it's going to go here. And then it will, by default, it's a transparent. So VLAN 1 is the native VLAN. It will go, and then you will be able to reach the destination, and it will come back. But it doesn't come back this way because this one, it knows directly where 9.1 is, and it will just forward it out. This is kind of like looping it, but it's actually forward from one interface to the other interface. Okay, so it's because it's a router, so it will work. So let's try to after it's done, let's ping 104 again. And when it's working, we can do the simulation to see how the packet travel to help us understand. Yeah, it's working now. So now let's do the simulation, and let's do that again. So you can see the ICMP, and then because this is the only route, only connection you can actually reach 10.10.10.10, right? And now it's going to come back directly because it has that connection over there. So your ping is completed. So in here, now if you ping the 204 and 212, it will also work now. So let's try it. Well, pin the 204 is going to work without even adding any line because main reason is you are connected to it and you default gateway to it now. So you don't have to go through this one to find the 10, 10, 10, right? So of course, definitely this is going to work right away. Now the last step that we on our testing here is to ping the 10, 10, 10, 10 box. So let's try to ping the 10, 10, 10 box. So ping 10, 10, 10, 10, it should fail, even though you can reach it to 10, 10, 10, 10. But as we know, this one doesn't do NAT. So we're going to add a route into here for it to work. So we just go ahead and come here. And according to the document, actually, this is a review of our route. And we're going to just add a whole class B to it. Send everything back to 204. And after you've done that, then it should work, because then you know how to send it back to the 204. Okay. All right, so this complete the Vlan routing with the STP discussion on that. You can double check on this one. So if it's Vlan 1, it comes here. You don't want it to go through here. You want it to just form a single location, a single line, and it stops right here. Even though it's two different interfaces, that'll be okay. You can allow Vlan 1 here. It's still a good idea to separate them out. Even if you allow Vlan 1, your STP wouldn't complain because it's not on the whole STP domain with all the switches together. Okay, this completes our exercise.